Here we are on the roof clamping the solar panels to the rails, and you see here that we have potentially a problem if we didn't do some pre-planning. I mentioned earlier that you can only put hooks on top of trusses. Unless you get some bits of wood out or you start bolting bits of wood to the sides of trusses, that's where the hook's got to go. Well, you've got the same problem with the clamps. You can only put a clamp on a rail, and you can only put a rail on top of a hook, and a hook can only go below a tile. You can't put a hook sticking out the middle of a tile, it just wouldn't work. So how do we make sure that we respect the clamping locations that you get from the solar panel manufacturer's manual and still make that match whatever the pitch of the tiles is on your roof? Well, there's a couple of things to consider. The first thing is there's lots of different ways to mount panels. This one that I've circled in red here is the standard because it's nice and quick and generally works. But if you read the manual very superficially, you might be drawn into thinking that you've only got one option, and that's this option. For this particular type of panel, where it says on the spec sheet, you can clamp in this yellow box plus or minus 50 millimeters of this line here. Turns out when you read into it a bit deeper, you've got some other options available to you. You can actually use this other clamping zone, which is much wider, and that says that you can clamp anywhere in this much bigger yellow box. Why is that? Well, if you look at the spec sheet here, you can see that there's a whole bunch of different stresses or pressures that are able to be put on the panels. In this case, for my panel type here and this particular mounting location, they're saying that you're allowed to have a maximum of 2400 pascals on the front and 1600 pascals trying to suck it off the roof. Turns out that when you do the simulation, we're well below that, presumably because we're in a much less windy location than these panels were designed for, using that other more restrictive clamping location. So what you might say is, why don't we just put a clamp in the four corners of the panel, simplest possible thing, or wherever they fit with the roofing tiles? Well, it turns out that some people looked into this, some other previous engineers, and they came up with this thing called airy points and bezel points. But a big simplification of this here, if you approximate the panel to a 1D beam in bending, right, everything is a spring, everything is a beam in bending for approximation purposes, and you support it at the ends, you get quite a large deflection, the most deflection possible. Okay, obviously that's a stupid idea. Let's do thirds, right? Let's do 1/3 in from the edge, and then 1/3 on to the next one, and then 1/3 to the opposite edge. It does give you less deflection, but it's still not as little as if you use something like an airy or a bezel point. Now, the manufacturer's instructions aren't quite this, but they are very close, and ultimately that's what we have to do. We have to follow the manufacturer's instructions, so that's why we're using these prescribed zones here. How can we be so confident that we know that we're safe to use this set of clamping zones and not this one or this one? Well, it comes down to the load on the panels. And that's another nice thing that we get from Renusol. We get this simulation where for the wind speeds and snow loads that you put into the computer, it will tell you how much pressure is going to be on the panels. And the other thing that it tells us is roughly where the panels are going to fall compared to the batten spacing. So if you remember, these grey lines are where the battens are and therefore where the tile pitch is. So we're one tile in from the edge, 1, 2, 3 tiles to the next one, and then 1, 2 tiles to the next one, and so on and so on. However, if I move those panels about a bit, we're going to end up off pitch, and you can see in this version here, we've got the rails really close to the edge of the panels. Probably it would still work, but it's not as optimum a solution as this, where we're closer to those airy points and we're well within those recommended zones from the manufacturer. Just to really prove to myself that this was going to be okay, and also to understand a bit more about the loads involved, I wanted to do an extreme scenario. So I put in here snow load zone 6.5 and base wind speed 31 meters per second. And this is just weather that you would never normally see in the south of the UK. This is weather all the way up in the northern wilds of Scotland, but it does give us a bit of a handle as what would the pressures be if you were to get a storm like that. And you can see when the system crunches everything down, you get pressures that are still below what we were seeing on the manufacturer's instructions. It does make you wonder, what do people do in really extreme climates, hurricane force winds? There was a bit of a clue in the manual here. You can see from this 3-rail system where you've got 3 different zones that you can target. Obviously 3 support points on each side is going to lower the stress on the panel, and potentially that enables you to have these panels in much more extreme environments. The other thing that I came across from Renosol was this cross-rail system. I'm sure people in the comments can tell me more about either of these things, but I think this might be useful if you've got a really difficult roof. Maybe you've got a very wavy, wobbly roof, or trusses that are just completely inconsistent, and by having one set of rails wherever they go to meet the hooks, just wherever you're able to get a hook in on a truss, and a second set of rails where you need the clamps to go, you can float all of that inaccuracy out. You can move rails up and down, and that way you can overcome even the worst roof in the world. Another little detail here is something called an anti-slip bolt, and that is a small stainless steel or aluminium bolt that you put through one of the mounting holes on the panels. And you do need to get lucky and have that line up with a rail. It needs to be above a rail so that should the clamps fail and the panels slip, you don't have a great big avalanche cascading off your roof. So that's the end of day 2. We've got 8 panels on the roof. We've deliberately left those 2 off. We'll trim all the spare ends of the rails off at the end. And it just means that we've got a walkway to get over to the shallow roof. And then you couldn't see it because it was dark, but this is how much moss is up here. This house was built in the 70s. Probably don't have to do it, but if you imagine when this gets shaded and it all dies and rolls its way to the bottom edge of the panel and then gets stuck on the bird netting, either it's going to affect your efficiency because the light won't reflect off the roof into the bifacial, or at worst it might short something out or create a problem. So sweep it is, unfortunately. Okay, all you clever people in the comments, which side's the swept side? But yeah, I think especially on this roof it's definitely worth doing. If you imagine that scaffolding rail was the bottom of the panel and all that is all tightened up, it's probably 2 buckets worth there. Could cause a problem. And also I think this is a much more reflective surface than that, so you're going to get more efficiency from the bifacial on the back of the panel. It's a sweaty job though. One entire wheelbarrow of moss off the roof.